Now we are going to study question from December 2009 exam, question 9. It is also a little bit old exam question. So everyone give the heading December 2009 exam, question 9. Okay, this question is approximately similar to the previous question that we studied. But here a little bit there is a difference here in this question. So that's why I am taking this question. Now before going further, before solving this question or before watching this solution, you have to try to solve this question by yourself without watching this solution. First of all give 30 minutes and then try to see the solution or watch the solutions. So first of all attempt this question by yourself without watching the solutions and then try to see the solution, means try to watch this video. Okay, now I am going to read the question for you guys. A block of mass 2 kg. So here we have a block whose mass is how much? 2 kg, 2 kilogram. Moving between vertical parallel guides. See the scenario here. Here guides are what? Vertical parallel guides. Moving between vertical parallel guides is driven by slider crank mechanism. In previous question we studied what is meant by slider crank mechanism. Crank slider. So is driven by slider crank mechanism as shown in figure question 9. Figure question 9 is given. The block is assumed to move with simple harmonic motion with a frequency of 1.67 Hz. So here frequency is given 1.667 Hz, and we know frequency we studied in our theory. Frequency means what? Number of oscillations or number of cycles in per unit time or per second. Then stroke is how much? 120 mm. Stroke is equal to what? 120 mm. But mm is not our favorite, we have to convert it into meter. So 0.12 meter. The coefficient of friction between the block and guides is what? 0.12. So mu is equal to what? 0.12. Try to see the scenario here. At a certain instant, the block is 40 mm from the mid stroke. So here they have given us direct distance from mid stroke or fixed point. Another name for mid stroke is what? We will say fixed point. So distance from mid stroke or fixed point, what? How we denoted that distance? It is directly here we are getting a x. So x is what? Here x is what? What is x here? 40 mm. 40 mm means what? 0.04 meter. Try to see the scenario here. And moving towards mid stroke. So here block is doing what? Moving towards mid stroke, and rod is at an angle of 15 degree to the line of stroke. Now try to see the scenario. Very important discussion is here, and try to understand the scenario. Now here I am going to draw the drawing. That is, we should know exact position of the where should be our block should be where. Okay, I am going to draw the drawing. Before that I am just going to draw the block diagram here. Okay, where should be the exact position? It is below the fixed point or above the fixed point. And then I am going to draw our slider crank mechanism that is given in this question. So here first of all I am going to draw the line diagram. Try to observe the scenario here. So here I am showing a line diagram. This is what? Our top end or we can say TDC. This is what? Bottom end, we can say. Here we can say TDC, here we can say BDC. In bracket I will write down, or TDC, top dead center. Here we can say BDC, bottom dead center. Try to see the scenario here. Very simple discussion. Then this complete distance is what? This complete distance means what? This complete distance means what? What is meant by this complete distance? From BDC to TDC. Distance from BDC to TDC is what? Stroke, that is given. How much value of stroke is given? 0.12 meter. So here they have given us value of stroke 0.12 meter. So this distance is what? Our stroke. Okay, then exactly in between, which point is there? What we say? We will say mid stroke. Exactly in between, what we will say? This is what? Mid stroke. Another name for mid stroke is what? Or we will say fixed point. Okay. and then this distance, try to see the scenario here. This distance is what we will say. This distance is what? From here, from top end or TDC to mid stroke. This distance is R, and R means what? Amplitude of SHM. Again this distance means what? R. Then here, now where is the location of our block? Where is the location of our block? Above the mid stroke or below the mid stroke? So for that purpose we are going to see slider crank mechanism diagram that is given in the question. Okay, for that particular position, now I am going to draw the slider crank mechanism of the question. Okay, try to see the scenario here. Now I am going to draw that drawing. See this drawing, very important to us, this drawing. So this is what our guides. This is what a guide. In guide, this is what a block. See the scenario here. This is what a block. In block is moving in the guides. This is just schematic diagram. Then this is what here I am showing a center line. Okay, this is what here they have given us. This is what connecting rod. Okay, this guide is connected to what? A connecting rod, or we will say operating rod. So this is what? This is straight line. It is not coming from my. Okay, so this is what? Then this is what? A crank. Okay, this is what? This is crank. Try to see the scenario here. This crank, this point of the crank is rotated. Suppose this is what our about this point, this crank is rotated. About this point, this crank rotate, and this crank rotate in a what? Rotate in a what? Circle. So this crank is rotating in a circle. Try to see the scenario here. Very simple discussion, not that much difficult discussion. Very important discussion. Now observe the scenario here. Sorry, my drawing is wrong. Okay, a little bit here. Okay, in 1 minute. So my drawing is, I have drawn little bit wrong drawing. Means drawing is okay, but position, the current position that I have shown was wrong. So try to see the scenario here. And this is what our crank. Okay, this angle is how much? This angle of this connecting rod, this is 15 degree. It is given in the question. This angle is what? 15 degree. It is given in the question. Try to see the scenario. Very simple discussion, not that much difficult discussion. Now here in the question, in the diagram, if you observe in the diagram, what they mentioned, how the direction they mentioned, how the crank is rotating. Crank is rotating like this. Rotation of the crank is like this. So this is omega. So crank is rotating like this. And in the question what they mentioned? Block is moving towards mid stroke. See what they mentioned, block is moving towards mid stroke. So according to this drawing, if you observe this drawing, how is the motion? How is the motion of the block? Motion of the block is what? How is the motion of the block? Motion of the block is upward. See, if you observe this drawing, according to this drawing, how is the motion of the block? Motion of the block is what? Upward. Means for this current scenario, means when crank is rotating like this one, so block is going upward. So motion of the block is what? Upward. Block is going upward. When block is going upward, and in the question they mentioned what? Moving towards mid stroke. What they mentioned? Moving towards mid stroke means what? What does it mean? Moving towards mid stroke means what? So motion is going upward, and in the question they mentioned moving towards mid stroke. So it means what? Moving towards mid stroke means what? What does it mean? Then what does it mean? It means our mid stroke is above the current position. Means suppose this position, with respect to this position, it is above. So try to see the scenario. So where should be? So our position, current position, which is 40 mm from the mid stroke, Where should we have to denote? Above the mid stroke or below the mid stroke? So it must be below the mid stroke, then and only. So here, so this will be our current position of the our block. We will say, we will denote this position by P, and this distance we will say, what this distance we will say? This distance we will say as a x. So x will be equal to what? This is x is equal to 0. What we will say? X is equal to 0.04 meter. It is given in the question. Okay, try to see the scenario. Very, very simple discussion. So from this drawing, we came to know that what we got? We got the exact position. And why we need exact position? See, in A part they ask us kinetic energy, and in B part they ask us force in the operating. In A part they ask us kinetic energy of the block, and in B part they ask us force in the operating rod. Means this rod. In this rod they ask us force in the operating rod. But during calculation of forces, we need an acceleration. We need the direction of acceleration in Newton's second law of motion. And to get the direction of acceleration, we should know exact position, whether it is below the midpoint or it is above the midpoint, because we know direction of acceleration is always towards the fixed point. Okay, always towards the fixed point or mid stroke. And why we need a direction of acceleration? Because sign convention of forces in Newton's second law of motion equation depends on direction of acceleration. Means forces in the direction of acceleration we consider it as positive, and opposite forces we will consider as a negative. That is what we studied in this chapter. So here, forces in the direction of acceleration we will consider positive, and opposite forces we will consider negative. Try to see the scenario here. So this is what our drawing. Now try to see the further scenario. So now we got, so in A part, what is our target? In A part, our target is what? We have to find out kinetic energy. So kinetic energy means what? Half mv square. And in B part, we need a force. For force, we need an acceleration. So before going further, we have to find out value of velocity and acceleration. We need a velocity for A part, we need an acceleration for the B part. Try to see the scenario here. Now before going for the velocity and acceleration, for getting velocity and acceleration, what we need? We need an amplitude value of R. R means what? Amplitude of SHM. And then we need what? Omega. Omega means what? Angular velocity. So how to calculate? First of all, we will calculate R. R means what? Amplitude of SHM. Amplitude of SHM will be what? Stroke by 2. What is the value of stroke here? 0.12 meter. It means what? 0.12 by 2? 0.06 meter. Then omega will be equal to what? 2 pi f. From frequency, they have given us a frequency. From frequency, we can calculate omega. So 2 pi, value of f is how much they have given? 1.667. So omega will be equal to what? So please try to do the calculation with me. Everyone, please try to do the calculation with me. 2 pi into 1.667. How much value we are getting? 10.474 unit omega radian per second. Try to see the units. So here what we got? We got the R and omega. What we got? R means what? Amplitude of SHM. And then we got omega. And from R and omega, what we are going to calculate? We are going to calculate the velocity. Velocity means what? Velocity of the block at this particular instant means distance x from the mid stroke. So velocity will be equal to what? Omega under root of r square minus x square. So velocity omega is what? 10.474. 10.474 under root of r is what? 0.06 square, x is what? 0.04 square. So everyone, please do the calculation for the velocity, and in this way we will get the value of velocity. So 10.474 into 0.06 square minus 0.04 square. So how much value we are getting? 0.4684 meter per second. So in this way we got the velocity. From velocity, okay, from velocity we can easily find out kinetic energy. Then now before before getting the kinetic energy, what we are going to do? We are going to calculate acceleration. We need the acceleration for B part. Acceleration means what? Omega square x. So 10 point. So acceleration is equal to 10 point. So what is the value of omega? 10.474 square. X is what? 0.04. See x 0.04. So acceleration will be equal to what? What will be the acceleration? 10.474 square into 0.04. How much value we are getting? 4.3881 meter per second square. So in this way we got the acceleration. Now in A part, what is our target? We have to find out kinetic energy of the block. What is our target in A part? In A part we have to find out what? Kinetic energy of the block. And how to get the kinetic energy? Kinetic energy means what? Half mv square. Kinetic energy means what? Half mv square. So kinetic energy, half mass is what? Here mass they have given. M is what? Mass is what? 2 kg. So 2 into what? Velocity is what? Here we just now calculated 0.4684 square. So velocity square. So this 2 we can cancel. So everyone please do the calculation. So this 2 we can cancel. So at the end kinetic energy is what? 0.4684 square. How much value we are getting? 0.2194. Unit of energy will be what? What will be the unit of energy? Unit of energy will be joule. What will be the unit of energy? Joule. So in this way we got our A part answer. Very simple discussion. Nothing much. So now how you have to solve? First of all, what we have to do? First of all, write down all these things. First of all, this one. Then try to draw this drawing. Draw it properly. Try to understand why point P is here. Why not here? Because I am explaining once again. Why point P is here? Why not here? Why not above the mid stroke? Why it is below the mid stroke? Because see, if you read the question, what they said, block is moving towards mid stroke. And from this drawing, how is the motion of the block? Motion of the block is what? Block is going upward. If you observe this one, so here crank is rotating like this. If this crank is rotating like this, so this block will go upward. Try to see the scenario. Very simple discussion. This is what a block. This is what our connecting rod or operating rod. So this block is going upward. So if the block is going upward and moving towards the mid stroke, it means what? The current position must be below the mid stroke. Current position of the block must be below the mid stroke. Try to see the scenario. Here, very simple discussion. So now how we have to do? First of all, write down this one up to omega. Then try to draw this drawing. After the drawing, calculate, write down this calculation of V, then calculation of acceleration, and then this kinetic energy, this A part. Don't draw this drawing. Don't draw this drawing. We have to draw this drawing up in the B part because we have to add lot of things on this drawing of forces and all that things. Okay, so first of all this one, then this drawing, then calculation of velocity. Don't draw this drawing. And then this one. Okay, don't draw this drawing. Don't draw this drawing. So everyone please complete this point. Now in B part, what we have to find out? Force in the operating rod. So in B part our target is what? What we have to find out? We have to find out F rod. Okay. So now here we are going to complete this drawing. So our target is what? We have to find out force in the operating rod. So how is the force here? So this will be force. Try to see the drawing here. Here this one will be force. So this one. Okay. So this one will be what? I am going to show it properly. Try to see the scenario. This will be straight line, inclined line. So this will be what? This will be what? This one will be what? Force in the operating rod, and this force we will say F rod. Try to see the scenario. Now then there will be what? How weight will act? Weight always act vertically downward. So weight will act. How is the mass? How much is the mass here? Mass is 2 kg, 2 kilogram. So weight will be what? 2g. How much will be the weight? Weight will be what? 2g. So weight will always act. Okay, let me draw it properly. It must be straight line. So weight must be what? Weight must be what? Vertically downward. So this is what our weight. That will be what? 2g. So try to see the scenario. So weight is what? 2g. Now here where we can represent frictional force. Now this point is very, very important. Where we have to show normal reaction and where we have to show frictional force. Okay, before that, where we can show, see here this block or guide, this block, this block is contact with both the side of guide. So this is contact with this side also, on this side also. Now where on which surface, on this side or on this side, on which side friction force will develop. So try to understand the scenario here. Now for that purpose, what we are going to do, we are going to show this is what our F rod. We are going to replace this F rod by its two component. Okay, what we are going to do, we are going to replace F rod. So before that, I am going to show the directions here. So x direction is like this, okay, horizontal, and y direction is vertical. X direction horizontal, y direction vertical. So now what we are going to do, we are going to replace this F rod, because this F rod neither in x nor in y. What we are going to do, we are going to replace this F rod by its two component. And so for that components, so this is what here I am drawing, this is what our F rod. Try to see the scenario here. And here force is approaching inward. When the force is approaching inward, so how we are going to represent the component? We also represent the components also going inward. So as the force is going inward, so how we are going to represent? It is not compulsory that we should represent component also going inward, but it is very easy to understand. As force is going inward, component must also go inward. It can go, we can show outward also, no problem, but it is always easier to understand. As the force going inward, components also go inward. And how to get the component? For getting component, what we are going to do? For getting component of this F rod, what we are going to do? We are going to form a rectangle. Try to see the scenario here. This discussion is very, very important. So here we are going to form a rectangle like this. Simple discussion, guys, not that much difficult discussion. So this is what a rectangle we formed. Okay. Now here this angle is what? This angle is 15 degree. They have given us in the question. This is what, a 15 degree. So F rod has two component. One component is like this. One component is what? Horizontal component. And another component is what? Vertical component. All the components are going inward. Okay. As the force is going inward. So this component here, angle is with respect to what? Vertical component. So this component will become F rod cos 15. Try to see the scenario. Otherwise you may say, sir, this must be sin 15 and this must be cos 15. No, it is not like that. The angle with which, here angle with respect to what? Vertical. So vertical component is what? F rod cos 15, and then remaining component will, another component will become F rod sin 15. Try to see the scenario here. Now if you observe this one, see what is the speciality of F rod sin 15? How, in which direction F rod sin 15? F rod sin 15 is in these directions. So how is the direction of F rod sin 15? F rod sin 15 is in this direction. F rod sin 15 is in what? Is in this direction. So if this F rod in sin 15, so what this F rod is going to do? This F rod sin 15 is going to do what? This F rod sin 15 is going to do what? It is going to push this block, going to push this F rod sin 15, going to push this block on this side. As this F rod sin 15 is going to push the block on this side, so what will happen? Automatically what will happen? See, if I am going to push this board, if I am going to push this board with some force, automatically what the board will do? Board will apply opposite force on me. Means apply normal reaction on me. Means when I am going to push this board, then board will apply reaction on me. So this F rod sin 15 is going to do what? Going to push this block on this side. So automatically what will happen? On this side, normal reaction will develop. So are you getting my point? Try to see the scenario. Why normal reaction is developing on this side? Why normal reaction is developing on this side? Why normal reaction is developing on this side? Because our F rod sine 15, see on this side on this side F rod sine 15 will act. See this side F rod sine 15 is going to push this block on this side, okay, on this surface. So this surface automatically, this surface of the guide, what will do? That will apply opposite force, and that opposite force will be what? That opposite force will be what? Normal reaction. The opposite force is what? Normal reaction. See, means what? Here this F rod, not I am, this F rod sine 15 is going to push this block on this surface, So what this surface will do? This surface will apply opposite force, opposite direction force. Are you? Okay, guys, are you getting my? Try to see the scenario here. And so we can say, so this surface is in more contact with as compared to this surface. Okay, this surface of the guide, this surface, this side of the guide, or this surface of the guide is in more contact with the block as compared to this one. Means we can say this side is in just contact. This side is in what? Just contact. So that's why no normal reaction, no friction force. Or we can say negligible friction force. So where friction force will develop? Friction force will develop on this side. And how this block is moving? This block is going upward. How is the motion? Motion of the block. See, this crank is going like this. Initially they have not mentioned motion of this block. From this diagram, from this omega, we come to know that this motion of this block is going upward. If the motion of the block is going upward, then how will be the scenario of the friction force? Friction force must be in downward direction. How will be the friction force? So friction force must be downward direction. Try to see the scenario. So this will be what? Our friction force. So this will be what? Our friction force, and friction force is what? Fr. Fr means what? F suffix R. Don't get confused. This is F rod force. Okay. Operating rod force. Fr means what? Mu Rn. We studied all these things in our friction chapter. Fr means mu Rn. Now try to see the scenario. So we got it. So on which side there will be friction force? This side or this side? So friction force must be on this side, because this F rod sine 15 is going to push this block on this side. So this side is more contact with the, so this side is in more contact with the block. So as it is more contact with the block, what will happen? Automatically friction force will be there. Try to see the scenario here. As compared to this is just touching scenario. In just touching scenario, no normal reaction, no friction force. Are you getting my point? Try to see the scenario here. So we got it, this one. Now everything is easy now. All the forces we have shown. So now what we are going to do? We are going to apply summation of forces in y direction and summation of forces in x direction. Now try to see the scenario here. Is there any motion in x direction? Is there any motion in x direction here? There is not any motion in x direction here. So summation of forces in x direction equal to 0. As there is not any motion in x direction. Now there is an acceleration in y direction. Now in which direction acceleration is there? See, try to see the scenario here. Okay, I have erased that drawing, but try to see the point here. So this is what our midpoint. This is what our midpoint, and this is what our point P, position of the block. So where is with this is the position of the block. This is the position of block. With respect to block, where is our midpoint or mid-stroke? Where is midpoint or mid-stroke? It is above. And we discuss acceleration is always towards the mid-stroke. What we discuss, acceleration is always directed towards mid-stroke or fixed point. So where should be the direction of acceleration? Acceleration direction must be in the same direction as the motion. So it is not compulsory that acceleration and motion direction is same. Acceleration and motion direction may be same, may not be same. But the one important point is that in case of simple harmonic, see, in case of linear motion, whatever the direction of motion, same we will consider direction of acceleration. In case of linear motion. But in case of simple harmonic motion, how we are going to take the direction of acceleration? Here we are going to take the direction of acceleration towards the fixed point. Okay, if this point P instead of here, if this point P is here, then what will be the direction of acceleration? Acceleration of direction is downward. For this scenario, acceleration is upward. Okay, so this is the direction of acceleration. And why we need a direction of acceleration? Because in Newton's second law of motion, for the summation of forces, we have to take the sign convention. For that sign convention, forces in the direction of acceleration we will consider as positive, and opposite forces we will consider as a negative. Are you getting my point? Try to see the scenario. Very simple discussion. So here we got the direction of acceleration upward because our point P is below the fixed point and it is going. So acceleration always directed towards the fixed point. Now, so here we are going to start our discussion is with what? Summation of forces in x direction. Why we are going to consider summation of forces first? Because we are going to need Rn. From Rn we are going to find out Fr, and from Fr we are going to find out F rod. Fr means friction force. Fr means what? Friction force. Friction force means mu Rn. Try to see the scenario here. Now, is there any motion in x direction here? The motion is only in y direction. So, as there is not any motion in x direction, it means what? Summation of forces in x direction is equal to what? 0. Our equilibrium situation will become. So, summation of forces in x direction equal to what? Summation of forces in x direction equal to 0. So, what are the forces here in x direction? So, first of all, this Rn is in what? Negative x direction. Then this 2g, negative y direction, Fr, negative y direction. So, this F rod neither in x nor in y. What we have done? We replace this F rod. What we have done? This F rod neither in x nor in y. We replace this F rod by what? Its two component. One component is in x direction, another component is in y direction. So, this F rod sin 15 is in what? Positive x direction. So, first of all, we are going to write down F rod sin 15. Then what will be the another force? Another force in x direction is what? Rn. So minus Rn, negative x direction here because it is on this side. So equal to 0. Try to see the scenario here. So Rn will be equal to what? F rod into sin 15. Now please everyone do the calculation and tell me the value of sin 15. Everyone do the calculation and tell me the value of sin 15. What will be the value of sin 15? Sin 15 is equal to 0.2588 F rod. So in this way we got the normal reaction in terms of force in rod, F rod. Then Fr will be equal to what? Mu Rn. Mu is what? 0.12. So mu Rn. So 0.12. How much value of mu? Friction coefficient of friction 0.12 into Rn is what? 0.2588 F rod. So everyone please do this calculation and tell me the 0.12 multiplied by 0.2588. 0.12 multiplied by 0.2588. 0.031056 F rod. So 0.031056 F rod. Try to see the scenario here. So we got Fr. After the Fr, what we are going to do? We got the Fr in terms of F rod, friction force in terms of F rod. Now we are going to take summation of forces in what? Y direction is equal to ma. Okay, because acceleration is in that direction. Now forces in the direction of acceleration we will consider as positive. So this F rod cos 15 is in positive acceleration direction. So F rod, try to see the scenario, very simple discussion. F rod sin 15, F rod, sorry, not sin 15, F rod cos 15. Then what will be the next point? This 2g minus 2g. Then minus Fr is equal to what? 2 times. Mass is what? 2 times. And what will be the value of acceleration? We calculated. Okay. Before the A part, acceleration is what? 4.3881. We calculated. So F rod cos 15 value is how much? Everyone please do the calculation of for the cos 15. Cos 15 will be how much? 0.966 minus 2 into g is what? 9.81 minus Fr. Fr is how much? 0.031056. 0.031056 F rod. And please everyone calculate this 2 into 4.3881. 2 into 4.3881. 2 into 4.3881. How much value we are getting? 8.7762. So 0.966, yeah, fraud. Then this term will become 19.62 minus 0.031056. We are nearer to the answer. Is equal to 8.7762. Try to see the scenario here. So, yeah, fraud term on one side 0.966, yeah, fraud, minus 0.031056, yeah, fraud, is equal to 8.7762 plus 19.62. So 0.966 minus 0.31056. How much value we are getting? 0.934944, yeah, fraud. Then 8.7762 plus 19.62. How much value we are getting? 28.3962. So in this way, yeah, fraud will be equal to what? 28.3962 divided by 0.934944. How much value we are getting? 30 point. How much answer we are getting? 30.372 unit. Force unit is what? Newton. Okay. In this way, we got the force in the operating rod. Very, very simple discussion. Now, how we are going to write down the things? First of all, as usual, target. First of all, target, that is what our target. So always in the beginning, write down the target, yeah, fraud. Then after the target, try to draw this bigger drawing. This complete, all these things on the board. So first of all, this drawing, beside this drawing, try to draw this drawing, components of the forces, component of this, yeah, fraud. So this drawing and this drawing, all the things. Okay. Then after that, this one, summation of forces Rn, then Fr, then summation of forces in y direction, and then F rod. So first of all, this F rod, after that this drawing, then from this one, then this one. Okay. F rod, F rod, drawing, summation of this one, and then this summation of Fy. So please everyone complete this point.